Hey, hi everyone. It has been quite a long time. I had uploaded any videos into my channel. So in my today's session, I'm going to explain about the command design pattern. So let's start with it. So what's a command design pattern? As per the Gang of Four, command design pattern is used to encapsulate a request as an object and pass it to an invoker, wherein the invoker does not know how to serve the request, but uses the encapsulated command or request to perform an action. Okay, so the request basically contains the mechanism of how to perform that action over here, guys. The command pattern is a behavioral design pattern in which an object is used to encapsulate all information needed to perform an action or trigger an event at a later time. Okay, that object is basically a request or a command object here. This information includes the method name, the object that owns the method, and the values for the method parameters. Okay, so this request object basically contains a lot of information in order to fulfill that action. So all those things are encapsulated by this request or basically our command object. So what problems does command pattern solve? Okay, coupling the invoker of a request to a particular request should be avoided. Okay, what they are saying is coupling the invoker of a request to a particular request should be avoided. Okay, this invoker or the one who basically triggers the request he should be decoupled from the request which he want to execute basically. That is, hardwired request should be avoided over here. It should be possible to configure an object that invokes a request with a request basically. Okay, there should be a mechanism or there should be a possibility to configure an object with a request. Okay, so what solutions the command pattern provides basically? Okay, so define separate object that encapsulates a request. So in this case, that object is basically a command object. A class delegates a request to a command object instead of implementing a particular request directly. Okay, for example, take an example. You are a user of a MS Word application. Okay, you are basically using the MS Word application to perform various operations on your file, a Word file. Okay, so basically whenever you want to save, whenever you want to print, whenever you want to add header and footer. Okay, so instead of directly performing that particular operation by directly connecting to those services like print services, header footer rendering services, what we do is basically we delegate a request to a command object. We basically create various command objects like save object, save command, print command, header command, footer command. Like this, we create various commands. Okay, and those commands will take care of communicating further with the receiver object to fulfill all those operations. So that's what they say. A class delegates a request to a command object instead of implementing a particular request directly by itself. This way, if it directly implements that request, then it is basically hard coded with the receiver. We don't want that. Okay, that's why we should be having an object, or I would say the command object. We should take the responsibility of, okay, delegating the request to the receiver object. So I will go through the UML class diagram. Very simple, guys. Okay, here is the invoker. So basically the command pattern deals with multiple parts. That is, first one is the invoker. Okay, so in case of MS Word, this is basically your toolbar or a menu bar. Okay, so invoker is a toolbar or menu bar which invokes a command which is save, print, format painter. Okay, and apart from that, there are a lot of commands available. So just for example, I'm giving all these things. So these are the commands basically: save, open, print. Okay, then that command will basically contain the receiver object. Okay, which can fulfill all these objects like printing of your document, saving your document. So what happens when you call the commands execute method? That's over here, the command one dot execute. Okay, what happens is it internally calls the receiver object's action method in order to fulfill that request. So let's take an example of saving the document. Okay, so as an invoker, so I have a toolbar. Okay, my invoker is toolbar. On the toolbar, I have an option to save my document. I click on that save command or save button basically. So what happens? My save command over here internally calls a method called execute. Okay, and that execute method basically triggers an action of save basically on the receiver object or your MS Word object, I would say basically, or the save service, I would say. So this command object basically contains a save service which is called your receiver here. So when you click on the save button, this execute method will be called, and that execute method internally calls the save service dot save, that is receiver one dot action over here. So in our practical example case, save service dot save, okay, and that save operation will happen on the receiver, which is our save service, and that actually performs the saving of your contents. Very simple, guys, okay. Instead of this invoker directly accessing this receiver like this, okay, what we are doing, we are basically decoupling the invoker, okay, from the request or the action that needs to be implemented by the save service. So what we are doing, we have decoupled them, and we put one command object in order to further take care of that request basically. So the timeline diagram, very simple. Invoker, okay, invokes the command, that is on the toolbar you click on the save button, okay. So the save button internally contains a command which has a standard method called execute. It calls that method, and that command, the save command, also contains the receiver object within itself, and that execute method will call that save services, that is the receiver objects, services save method in order to save the document. So this is the timeline diagram basically, okay. I hope it's pretty much clear for you people. So four terms always associated with the command pattern, which are command, receiver, invoker, and client, which I have already explained. Okay, what is invoker, what is command, okay, and then who is the receiver, and also who is the client. Okay, so let's go through them once again. A command object knows about receiver and invokes a method of the receiver. Okay, values for the parameter of the receiver's method are stored in the command. That's what I am saying. Okay, if you take an example of save command, okay, this is the command basically. This command object basically, in case of our scenario, save command basically contains a reference to your save service, or it holds the object of your save service within it. So when its execute method is called, this execute method basically dispatches the save request to your save service by calling receiver one dot action one, which means your save service dot save method. Okay, so that's about the command. The receiver object to execute this method is also stored in the command object by aggregation. That's what I said. The object reference or the object of receiver object or save service will be in your command object basically, in order to be in order to be called from the command object's execute method. Okay, so that's what they are saying. The receiver object to execute this method is also stored in the command object by aggregation. The receiver then does the work when the execute method in command is called. An invoker object knows how to execute a command and optionally does bookkeeping about the command execution. The invoker does not know anything about a concrete command. It only knows about the command interface. That's it. Yes. See, your invoker or your toolbar only knows about a list of commands like save command, print command, copy command, cut command. Okay, all these kinds of commands are there, and all those commands basically inherit from a contract called command, which contains only one method execute. So for an invoker, okay, all the actions, okay, or all the functionalities are basically a list of commands. Okay, so whenever based on the requirement, okay, based on the requirement or sometime some later point of time, when you perform some action, it simply locates that command and calls its execute method. Okay, your invoker doesn't know how your request will be fulfilled. Okay, always remember this point. If you click on the save button in your MS Word document, okay, your toolbar which contains your save button doesn't know how that operation will be saved. Okay, its job is to just trigger the save command or the save button, that's it. And that save command will call its execute method. Okay, and that execute method will internally call the save services save method in order to save the document. And also this save service also requires some parameters like the content you want to save. In this scenario, I'm telling you, in case of save scenario, the content you want to save and the file name. Like this, you can pass the parameters also. Okay, but the uniform contract of the command will remain same for most of the commands you basically associate in your invoker. Okay, so your invoker only knows about a command object and its execute method. That's it. So let's move on. Invoker object, okay, yeah, the invoker objects, command objects, and the receiver objects are held by a client object. Yeah, one more important thing, the invoker objects and the command objects and receiver objects are held by a client object. The client decides which receiver object it assigns to the command object. Yes, this is a configuration step, guys. I'm going to explain with the demo because it makes sense over there. Okay, so the configuration of the invoker object, okay, the command objects, and what kind of receiver object should be configured, it's all decided by your client object. In my case, it's a main method of my console based application. So for which invoker, in case of, let's take an example of MS Word itself. In case of MS Word toolbar, which is an invoker, it is the client which decides this toolbar should contain what all commands, like save, copy, paste, print, all this kind of commands. So what all commands should be associated with your invoker, and for each command what services basically or what receiver objects needs to be associated, all these things should be configured by your client object only. Okay, so that's all about this. The client decides which commands to execute at which point. Okay, apart from this configuration, it's the client program which decides which commands to execute at which points. To execute a command, it passes the command object to the invoker object. Okay, so that's all about our client programs basically, or the clients. So let's jump into a quick demo now. Okay, so let's start with our setup. I will refer my UML diagrams, UML diagram over here, guys. So let's go through this UML class diagram. First thing, I should have an invoker. Okay, no, let's start with the commands itself. Okay, first we will see what all commands I want. Okay, in order to provide various kinds of commands, I should have a public contract. Okay, I should have one contract through which all the commands will be implemented. So I will go to my interface called I command. Can you see public interface I command, which provides only two methods, execute and can execute. Execute actually executes that action, whereas can execute basically checks whether the user or the client is basically authorized to execute that action. So can execute basically returns whether you can perform that action or not. Okay, so these are the two important methods we have to take care when we basically design a contract for our command objects. Okay, so that is done. So next, let's go through the concrete commands now. Okay, so this is my command object. Then I will go to, yeah, one more thing, document object, the receiver object. Yeah, this is what I wanted to explain. Yeah, receiver object. The receiver contains the business logic. They know how to perform all kinds of operations. They know how to handle the request, that is performing the actual operation. So in MS Word, when you perform a open, okay, this document object knows how to open the document, how to save the document, and how to close the document. Okay, guys, so this is the receiver object who knows the actual business processing logic or performs the business processing for us. Okay, then comes our concrete commands now. Let's go through the concrete commands. For example, take an example of open command. Okay, so this open command basically implements the I command interface. And now see, the command object basically contains the receiver object through aggregation. Can you see private document, document object? Okay, your command must know the receiver object. Okay, if it don't know the receiver object, then calling the execute method, okay, doesn't help you to actually trigger that operation on your receiver object. Okay, so your command must know the receiver object. So that's what I have put a receiver object private document over here, and through the constructor of this open command, I basically initialize that command object or set that sorry, receiver object. Okay, I will set that receiver object. Then comes the can execute method. In this case, guys, I'm directly returning true, but this can contain some various business logics. For example, if you have put some authentication, or if you have set some accessibility levels, it happens in case of MS Word documents. Basically, in nowadays in Office 365, you can specifically specify what group of users can basically access this document. Okay, so you can specify that, so you can put that kind of conditions over here. So when a user is trying to access your document, just check whether the user's email ID is authorized to access this document. Yes, if it is authorized, if it is belonging to the authorized users group, allow him to open the file. Otherwise, just return false. Okay, when you return false, that command itself will become false, or it won't allow you to open that document. Okay guys, so this is the use of can execute handler basically. So this is my open command, which is very simple, contains a reference to receiver object, then initializes the receiver object through its public constructor, and then the execute and can execute methods. Okay, so give a keen observation to the execute method. Can you see this execute method is not doing anything else? It is simply, okay, it is not doing anything else by itself. What it is doing, it's simply taking your receiver object document and then it's calling that actual open operation on that. Okay, your command doesn't perform the open operation. It's basically the receiver object encapsulated by your command object that will perform the actual operation. Okay, so that's the crux of this command pattern basically. So same thing I have done for the save command, and then I have done for the close command. Okay, in order to close the document. Okay, so now comes the most important part, the invoker. Okay, so as I had already explained you people, invoker is the one who basically contains the configuration of various commands with him or her. Okay, so in my case, let's take an example of MS Word document. Okay, in that I have a toolbar. My toolbar is the invoker command, and sorry, the invoker basically. My toolbar is the invoker, and that toolbar contains various commands like save, close, print, copy, various commands associated with the uh, Word document processing basically. Okay, so in my case, my invoker is toolbar options. So can you see the class here? Okay, very simple invoker. The invoker is associated with one or several commands. It sends a request to the command. It's the invoker who sends a request to the command, and it's the command who sends the request to the actual receiver to perform the operations. Okay, so the sequence goes like that as per the sequence diagram. So my invoker is very simple, toolbar options. It contains three commands, that is open, save, close. So it is being initialized through the public constructor. Okay, and then when you click on the open button on your toolbar options, okay, on your toolbar options, when you click on the open button, okay, so on its click open, it basically triggers the open command dot execute. Okay, so the invoker cannot handle the request, so it internally calls the execute method of the command object. Okay, same applies for the save. When he clicks on the save button on the toolbar, the save command dot execute method will be called, and same for the close also, close command dot execute. Okay, and what happens when it goes to the execute method of the open command, which I have already shown you people. Okay, can you see over here? Okay, it simply forwards that request to the receiver object, that is document.open. If there are additional parameters or some data needs to be passed, that should be contained within the command object only. Okay, your invoker will never send any kind of such information. Your invoker just invokes the execute method on your command. That's it guys, always remember this point. If you see, all three operations, open, save, close, all are just triggering the execute method. That's it. Okay, they are not passing any parameters. But even if you want to pass any kind of parameters, I think those should be uniform across all the commands. Okay, so that's why usually it's a recommended practice, you just give a execute method. Okay, usually, and then your command will contain the all various parameters which are required, or the arguments which are required to fulfill the request in order to trigger it from the receiver object. Okay, so that's about this commands. Okay, and then comes the client program, very important. I think this is the place, or this is the program which basically takes the responsibility of configuration as well as triggering the commands. Okay, so just give a keen observation. First, I'm creating an instance of the receiver. Okay, I should be having my receiver up and running, then only I can serve my requests, right? So my receiver should be created first. So I created a document object, very trivial example. Then I will start creating the commands now. Okay, so first I will create a open command, that is open command equal to new open command. And what I'm doing, I need to pass the receiver, right guys? So I'm passing this document object as a receiver to it. Okay, so open, save, close, all these operations should be done by the receiver, right? So you have to pass the receiver object. Once all these things are done, now I have to configure my invoker, create the invoker instance by passing the command objects. So how I am creating my invoker, that is toolbar options. I pass all three commands, open, save, and close. Now what I'm doing, using that toolbar options, or you would say toolbar, say toolbar options. Let me correct it quickly. Yeah. Now, what I'm going to do, using my toolbar options invoker, I will perform various operations like open, save, close, all these stuffs. Okay. Guys, see the configuration. Okay. You are basically decoupling your invoker, that is your toolbar options, from the receiver who actually performs those actions. And how you are decoupling? By using the command pattern over here. Okay, so that is the various separation of concerns we are seeing over here. So let me run this now. So let's say .NET build. So my build is successful, guys. So I don't have any error. So let me run .NET run, and I should see the results now. So as you can see, so first I clicked on open, then I perform the save operation, then I perform the close operations. The same stuff you would see over here, document open, saved, and then closed. Okay, so that's the stuff. I think that's the crux of command design pattern, which is a behavioral design pattern, guys. So this is how things will go. You are basically separating your invoker object from its receiver. Okay, they are not coupled to each other. Okay, so in order to avoid that coupling, what you have done, in order to decouple them, you are making use of the command design pattern. So whenever you perform any option on your invoker, first it will be triggered on your command object, and the command object, which basically triggers the same action, or which basically requests that operation on the receiver object, and the receiver object will take the responsibility of fulfilling that. Okay, I think this is pretty much clear for you people. Okay, so if you want to if you want to see a flow, let me quickly show how the program flow will go. Okay, so this is the setup I did. What I did, I clicked on toolbar options dot click open. So if you go to the, yeah, if you go to the implementation, can you see what I'm doing here? Using the open command, which is over here, open command dot execute I'm calling. So if I go to the open command, where is the open command? Over here, yeah. So what, in the execute method of the open command, basically you are simply making use of receiver object and you are calling the open method. Okay, so this is the flow, basically how this program will execute for various commands. Okay, and do remember, if you have any business validations, definitely you can make use of can execute handler, guys. Okay, so that you can disable that button itself, okay, based on the execution result of this can execute. Okay, so that is one stuff I think I wanted to highlight. Okay, so let's go to the PDF, and let's see what are the advantages of using the command pattern. Okay, so when we want to parameterize objects according to the action performed, okay, we can parameterize objects according to the actions performed. So basically you are creating I would say you are, the way you are going to parameterize objects in such a way that based on the operation you are going to perform. Okay, so in such scenarios you can make use of that. Create and execute requests at different times. Okay, Yes, you create the request. For example, if you go to this example, you created various requests like open command, save command, close command, but it's up to you when you are going to execute. So this execution can happen at any later point of time, right? So that's what, when you have these kind of scenarios, yes, basically you can make use of the command design pattern. Sending requests to different receivers can handle in different ways. Okay, sending the request to different receivers, and those receivers can handle these in a different ways. Okay, in this scenario also we can make use of that. And the support of rollback, logging, or transaction functionality, yeah, in order to support this also we can make use of command design pattern. In order to implement callback functionality, yes, we can make use of this. And most important thing is the source of the request should be decoupled from the object that actually handles the request. I think this is the most important yeah, uh, requirement for which we basically make use of the command design pattern. So some real world usages of this pattern is GUI buttons and menu items. So if you are familiar with the WPF applications in Microsoft, WPF itself gives a standard interface called I command, which contains execute and can execute methods. Okay, so all WPF controls can make use of that command, and and using those actions. So whenever you perform an action on a button, okay, those actions will be sent as yeah, encapsulated as a command object, and the command objects will take the responsibility of fulfilling those actions by making use of receivers, okay, or services you would say. Macro recording, yes, you would have seen the MS Word macros. You basically perform various, you basically go through a sequence of operations which needs to be done on a MS Word document, okay, and when you play that macro, it will perform all the operations in sequence. So all these tasks basically which you are specifying in a MS Word macro, they can be encapsulated as commands basically, and yes, can be used for the macro recording purposes. So multi-level undo, yeah, undo redo operations can be performed using the command objects. So what you need to do is, only in this command interface which I had used, it contains execute, can execute, but you can introduce a undo redo methods also over here. So whenever a undo method is called, it should basically uh, roll back the recent operation done on your receiver object. Okay, so that can be done using the undo, yeah, that can be done using the command pattern also. Only thing is you need to introduce those methods like undo and redos over here. And what else? Parallel processing. Yeah, I think if you people are familiar with .NET's task parallel library, I think every task you create is basically, it represents a command object, guys. It's a kind of command object. So when a thread is available, okay, that task object will be executed and it will fulfill the request. Okay. So progress bars. So in a progress bar, you would have seen a lot of progress bars in your day by day usage of your computers. Okay. So each and every activity of a workflow, okay, which uses a progress bar, can be encapsulated into a command object, and on fulfillment of that command object, we can basically fill the progress bar sections. Okay. Thread pools, yes, even thread pools make use of command pattern in order to execute synchronous operations and transactional behavior. Okay, yes, you can implement transactional behavior using command pattern. You basically specify a business workflow or a transaction as a sequence of command objects. Okay, when in the mid of a transaction, if any command due to some reason, if it got failed, then you have a mechanism by using these undo methods which I just explained. You can basically roll back that entire operation itself, guys. Okay, that entire transaction itself. So that's all about command design pattern. I hope you people understood the crux of this, and thank you for the listening, and have a nice day, guys.